Hi, class. Apologies for being late. I was assigned the wrong classroom. This one is not on me. Okay, but unironically, I'm so underprepared. Give me like 10 seconds. I don't even have Twitch chat open. I look like a geek? That's the goal! Jesus fucking Christ. Hold on! I was running behind schedule, and then I was running behind schedule. So someone let me catch my breath for like 5 seconds. Sexy teacher look. I'm glad you like it. I'm glad you like it. Alrighty. You would definitely skip my class? 3 misses in a row. 3 misses in a row and you're out. We're doing a lecture today. We're gonna do a little lecture today. I kinda didn't know what I wanted to do it on. You're gonna go back to holding on to your teddy bear as you can barely walk? Alright. No worries. Thanks for hanging around. You would come more often? Alright, hold on. Let's get ourselves set up here. We're gonna be doing a little lecture. We're doing a little lecture partially because professional looking good. Good. We're doing a lecture on the multi-producer, multi-consumer queue. I am so frustrated that no one understands what the hell I'm doing, that we have made a lecture that might not even fit in today's stream, but hopefully it'll be fun, hopefully it'll be entertaining, and hopefully you'll learn something. More trains, now you're afraid? Good. There will be a pop quiz at the end of the class. I'm so sorry. I'm so sorry. Oh yes, hello friends, hello enemies. Rewriting Kafka twice wasn't enough? Well, no, I rewrote it and now I need someone to like praise me for how cool it is. It's gonna be a good lecture. It's gonna be a good lecture. I genuinely, the hardest part of this is that you all are really dumb and it's hard to explain things to you. I'm kidding, obviously, but we do have a large variety in computer science knowledge. So a lot of my goal for today is not going to be to talk about specific technical things. It's going to be a lot more implementation, a lot more design focused. Hopefully it'll be interesting. Wow. Maxi, you are a mess today. Honestly, if I was a teacher, if I was a professor, I think this is exactly how my first class would go. I'd show up an hour late. I'd be like, I don't know what we're talking about, and then I would waffle for an hour. Don't worry, funny talking lady. I'm a professor. That's Professor Maxi today, okay? I expect everyone to call me Professor Maxi. I've earned this title by doing absolutely nothing. Great. Great. Let me get things set up here. Hi, Professor Yaps. Honestly, as long as it's Professor. As long as it's Professor. All right. Hit me with your best shot. Can I see like a preview? How does this work? I don't even get to see a preview. Oh, this is good. This is good. Professor Angry Curls. All right, let's do the fit. Fit check. Just don't look at the shoes. Mostly keyboard. I don't even need my mouse. Actually, that's a lie. I do. I'm disabling mostly keyboard for the stream. Everyone say thanks to Ryan for that one, assigning more homework. Too late. I'll refund you, bud. I'll refund you, bud. Don't worry. Long skirt. Yeah. Yeah. It's a maxi skirt. It's a maxi skirt. I need an ice cream to cool down. I need to catch my breath a little. I'm so sorry. I really don't like having such hectic starts to my stream. I'd like to be a little clear-headed. I like to just sit in my chair and ponder about life before I start stream, but a little bit all over the place today. Don't worry about that. Don't worry about that. I can't make such drastic changes and expect us not to react. Skirts maxi. Don't skirt class. You better not skirt class. We'll start the lecture probably in 10 minutes. It will be recorded. And if it's good, it might even end up on YouTube. I don't know. We'll see. I don't have a lot of faith in my teaching skills, but I guess we'll find out. I feel like I look so much more serious. I feel like having my hair down and the curls bouncing kind of like helps my dead eyes. Cuz otherwise I just have dead eyes and no bouncy curls. You feel like this is the beginning of a very special video? What does that mean? What does that mean? What is a special video? You're expecting a pure alien-style mental breakdown as I chaotically try to explain MQ? Hey, that's content. That's content. You're gonna come back in 10 minutes for mostly keyboard? It's off. It's off. Okay, so unironically, I don't know how long I'm gonna lecture for. If it really is gonna be a long lecture, I will stop after like an hour. If I'm fucking lecturing for longer than an hour, I'm gonna cut it off. We're gonna do something else. And maybe if this is fun. If this is fun, we can make this a recurring bit. I don't mind. There's a lot of things I can lecture on. I feel like barely anything fit into this lecture, and it was still a lot. So I'm okay with making this a recurring bit if we have a little fun here. I got a lot of weird knowledge in my head that I gotta get out somewhere. All right, hold on. I can't see you. Damn, I really do just look like a geek. You need a lecture on making a wall-sized tortilla? You have good friends who gift you a wall-sized tortilla. You need CSS power for your website. No, you don't. No, you don't. Just use the defaults. They're fine. Just use the defaults. They're perfectly fine. Dude, I actually have a question. Do we want music on or off for the lecture? Do we have a preference here? I wish I had like a chill playlist to do. Maybe some Joe Cocker. You would die if there was no music? Oh my god. Let's do some jazz. Let's do some jazz. Who doesn't like a professor that plays jazz in class? Can do jazz in the background. Aqua Barbie girl? No, I don't think so. I don't know if anyone follows me on Twitter. Lo-fi to study? Oh wait, that's actually a great idea. That's a great idea. Lo-fi to study too. I don't know if anyone follows me on Twitter. Toting did a tweet about how everyone in the software category just fucking yaps nowadays. I thought it was so funny. Retweeted and sent. Cause I personally, I'm not one of them. I'm not one of them. I'm here to teach. You've seen multiple software people go to the just chatting category instead? Iced tea. We're drinking Arizona, yeah. We're drinking some Arizona. Need a bit of sugar. Bit of sugar to balance out my spiciness. Alright, lo-fi girl, take it away. Alrighty. I think I've cleaned up a bit here. Cleaned up a bit. And I believe I'm ready to lecture. I would love to see a preview. There we go. Cool. Alrighty, class. Settle down. Welcome to the first lecture of Disk Multi-Producer, Multi-Consumer 101. The prerequisites for this course is to be a nerd. Sorta. The prerequisite to this course is a vague understanding of programs. This is not any specific language oriented. We're going to be talking about design a little bit. You don't have to ask me to go to the bathroom. This is a university lecture. You don't have to ask me. You're here because you want to be here. God, I would not be able to teach a freshman course, which is why this is, of course, not a freshman course. Will this be on the exam? Ask me during office hours, please. How did you get here? Well, you walked in. If you missed 3 lectures in a row, you will get an automatic F. That is in the syllabus. If you don't have the syllabus, I'm sorry, you've already lost the letter grade. You were supposed to hack it off my computer. I am kidding, of course. Please do not try to hack me. I do not give permission. Does the exam count 100%? It's all in the syllabus. I'm so sorry. I'm not going to repeat myself. It's all in the syllabus. All right. Quiet down, everybody. We got to get into this lecture. I don't have all day. Our classes aren't that long. Everybody, welcome to a message about a queue, aka a message about a message queue, a queue about a message, pubs and subs. Professor Maxi rambles about the on-disk multi-producer, multi-consumer. That's what we're doing here today. Hopefully you'll get something out of it. I don't know. I put a few of my own thoughts into here that maybe you'll find useful. I don't know. Who knows? We'll see. Just a few assumptions. What's the pride flag for pubs and subs again? I think it's the German one. Just like my teachers can't full screen the slides. Exactly. Can everyone see my screen? Can everyone see my screen? Please let me know. We have a few assumptions for the nerds, but you don't really need to know this. Everything I talk about today, we're gonna assume all the numbers are atomics, all operations on numbers are atomic, and everything else is just bytes. It really doesn't matter. But if you're a nerd, these are just some assumptions. This isn't actually true for the disk MPMC, but for our examples, it'll be a little bit useful. Question number 1. People always think that subs are fem. That is 100% a myth. I am personally, look, I present myself quite fem a lot of the time, but not all the time. I do enjoy presenting masculine sometimes. I like being a little bit of a tomboy, I guess. And I'm not going to confirm if I'm a dom or a sub. Yeah, great. Okay, moving on. What is the message queue? This is the first question on everyone's mind. The first question on everyone's mind when they enter the stream, and I'm talking about we're making a message queue. We're making a message queue, and people go, "What is a message queue? What is a message queue?" So I'll run through my little example that I give every fucking time, and I hope no one ever asks this question ever again. It's a fancy list. It's a double-ended queue. You push on one end, you pop from the other. For example, if you want to do a little pop operation, you're going to read the letter A, and then you pop, and you move on to the letter B. That's it. That's a pop operation. You just increment. You just move the little arrows. You do a push operation, it's the opposite. Oh, good job, Maxi. Nice job formatting that. Well done. Well done. You go to the end of the queue, you write the F, and then you increment the right index. That's it. That's a queue. It's just doing that. That's it. Okay, but like, what if we wanted to do this on disk? What if we wanted to do this on disk? When it's in memory, this is all nice and dandy. It doesn't really matter how big these are. These messages could be huge. They're just kind of just pointers. Really doesn't matter. You can write them all over the place. But I wanted to take it a little further. I wanted it on disk. What is a disk? It's a big blob of bytes. I swear to God, this was formatted correctly on my computer. A disk, so when you get a file, it's just a big blob of bytes. That's it. There's nothing to it. Just a big blob of bytes with a specified length. Here we have, this is not my computer. I was doing it on my laptop. And now it's all broken. It's just a big blob of bytes. And already we're running into issues. Of we need to know how big messages are. We need to know where messages are. We can't just do this nice little indexing that we got going on over here. All of a sudden, we're running into a lot of issues. Like Maxi not being able to format text correctly. We can solve some of these issues pretty cleanly. We'll just say like, oh, well, what if the message starts with the length of the message? Like if we wrote down ABC, we just write down the number 3 because there's 3 characters, A, B, and C. If we wrote ASDF, we'll write 4. You know, etc., etc. We know how long the message is. This is just a nice, clean way of keeping track of that. Okay. Number 2, where's the message? Where's the message? This is an important thing to keep track of. Oh my God, the formatting is gonna kill me. It's so over. We're just gonna split this up into a little table. We'll have a little table. I swear the diagrams will become a little cleaner later. Very hopefully. Very hopefully. We'll have a little table. We'll have a little table where we keep track of the message number compared to its byte value. This is a university lecture. You don't have to ask me to move. Just redo the slides in Vim. I should have done that, yeah. We want to keep track of where the message is. As in, the 0th message has a start byte of 0. That's over here. That's our little 3 ABC. The first message, this is 0 index by the way, the first message starts at byte number 4, that's this 2 AS. Third message starts at 6, that's this 5D, etc., etc. This is just a mapping of the message number to where it starts. Cool. So now we know how long messages are. We know where messages are. Let's actually write a few push and pop operations that are all going to be so poorly formatted. Oh no. Oh, it's so over. All right, class, look away. Class, look away. I'm going to fix this. So how's everyone's break doing? We feeling good? Need someone to teach me Google Slides? I don't know why it unformatted, okay? I don't know why that happened. It's just being funky. It's being a little funky. Why does it look like that? Why is this not PowerPoint? Is that just you pay $69,000 each semester? Honestly, less janky than some of my classes, I'll tell you that much. Libre Point. Okay, we're getting there. We're getting there. Don't worry. Don't worry about it. Boopity boop. Fix that. Fix that. Bada bing, bada boom. We only got like 1,000 more of these. You want your money back? Too fucking bad, bud. This is how real university works. You paid your money. Now lie in it. I just got here. Can you start completely over? Unironically, I had a class where someone kept doing that, and it was very funny. You know what? You know what? We will genuinely will restart because I didn't realize the formatting was this fucked up. So we'll give it another shot here. All right, class, talk amongst yourselves. Class, talk amongst yourselves. You're new here, you know. Go like socialize or something, whatever it is kids do nowadays. Wait at least 13 minutes for me. Unironically, I had a class where there was a kid who would always come in like 30 minutes late, sit down at the very front of the class and go, "Hey, teach. Can you repeat everything you said? I'm late." And then the teacher would like the professor would genuinely like be like, "Look, I can't do that. There's other kids." But then this kid just wouldn't take no for an answer and just consistently re-asked questions until it got to the point that the professor would try to speed run the entire class in the first 30 minutes. And then when the kid showed up, he would just be like, "All right, everyone else can go. I'm just going to lecture this kid now." I don't know how we lost that fight against a literal child, but it was funny. Who wants to go smoke weed in the bathroom? I mean, it's legal. You can do whatever you want. I'm not going to stop you. But if your grades suffer, Mr. NG, that's not on me. That is not on me. Sorry, there's a lot of slides to fix. It's going to be even funnier because you're going to see the slides and you'll be like, they kind of don't even look that different, Maxi. I don't understand why you were so hung up on this. They actually kind of look exactly the same. And I'll be like, shut the fuck up. They probably will. That's going to be awesome. Is it allowed to drink alcohol on campus? Probably not. This is a remote course though. I don't know why we keep asking these silly questions. This is a remote course. We will have breakout rooms later. Weed is okay, but alcohol is not okay. I think university policies just haven't quite caught up on that one. Fucking breakout rooms. You're leaving. I mean, you know, I'm not forcing you to stay. Not forcing you to stay. All I'm saying is attendance is mandatory and will be a part of the grade. Jesus Christ, how are these all formatted incorrectly? When does the lamp open? You need to sleep there since you can't find housing. Unfortunately, you're too poor for this university. So we won't accept you. Unironically, how universities work. By the way, before we make a decision on your acceptance, can you please fill out how poor you are? You're on a stipend from the Norwegian government. Damn, that oil money. Maybe you really are American, paying for school with oil money. We don't allow poors here, especially Euro poors. Jesus Christ! Drill, baby, drill. Crazy. How do we have so many Norwegians? What's going on? All right, I'm just about finished here. Just about finished here. We'll give it another shot. Ugh. God, being a professor sucks. Being a professor fucking sucks. You also have the smartest man on earth, Magnus Carlsen. Honestly, I don't think he's that good at chess. Most people have not been to an oil convention. I don't even know what that is. All right. We're fixed. We're fixed. We're fixed. I'm only an hour and a half late, okay? I'm only an hour and a half late. Let's get back to our pubs and subs, okay? Watch them be worse. They might genuinely be, but at least they make more sense to me. We're back. We're gonna ramble on Disc MPMC. You thought if the prof was 50 minutes late, we could leave? I mean, you can leave, but it will hurt your grade. That's all I'm gonna say. Quickly review. What is a message queue? Writing on one end, reading from the other. It's kind of like the human centipede. It's illegal for me to teach you after being late. What? Why is the Norwegian telling me about American law? Anyways, we're human centipeding here. We're reading on one end, writing to the other. Boppity boop. We pop an A. Great. Professor Maxi doesn't care about the law. We push on the other end. Great. Okay, it's like a disc. I didn't fix these slides. Can I show us the slide where I changed it? It's none of these. I'll tell you that much. Because we've already done these slides. Great. Let's do an example. Let's do an example. Here we have our little bit of data. We got a bit of data in this file. Imagine rerunning through slides you didn't even change. Don't teach me how to do my job, Mr. Ryan. I'll dock points for that. We have our little file. We got some messages in here. We got our ABC. We got our AS. We got our D, E, F, G, H. We got our I. This is just what it's looking like. We got our lengths of the messages here, and we got our map that's saying the 0th message starts at byte 0. The first message starts at byte 4. The second message starts at byte 6. And the third message starts at byte 11. This little star is just telling us where our producer, where our write count and our write index is. Write count as in the next message is the 4th message. The write index as in we're going to be writing to the 13th byte. And our read count is 0 because we haven't read a single message. Cool. This is just a little starting place for us. I think it'll be much clearer when we talk about an actual example. For example, let's push beef. Let's push some beef. This is confusing. It's so over. I think the examples will help. I think the examples will help, but all that really matters is this is all bytes. This is all bytes. This is raw bytes. Think of it as characters. We're gonna push the word beef. Can I repeat that? This is all bytes. We're pushing some beef. We're pushing some beef. How does push work? When we want to push a word like beef to our little, you take a bite of the beef, only a bit. You can take a bit of the beef, but not a bite of the beef. A bit of the bite of the beef. Great. How we push? How we push? 1, we write down the message length. Beef is 4 letters long. We write down a 4. Cool. The little brackets are just there to show that it's a number. That's it. It's just a visual thing. It doesn't really mean anything. We write down the message length. Beef has 4 letters. It's 4. Cool. We write down the message. We write beef. Great. And then we update the index of the map. We say that the 4th message starts at byte number 13. This is the 13th byte in this little list of bytes that we have. You can literally think of the file as just a long string of bytes. It's just a really big vector of bytes, and we have to do a bunch of fancy stuff to make sure we know which bytes are important, which bytes are words, which bytes are length headers, and that's all this fancy magic is doing, is we're just keeping track of where words start and how long the words are. And that's it. Cool. That's our little push. You smell like beef? You should get that checked out. You should get that checked out, Nylan. Are the write count and index on disk? This is all on disk. You can imagine it as being separate files. They're all vectors of bytes. You can just assume everything is a byte. This is just a file that has 1 byte. This is a file that has 2 bytes. This is a file that has a long list of bytes. And this is a file that has an even longer list of bytes. And that's it. You can just assume everything here is a byte for all intents and purposes. And then we update the write count and index. We're now writing the 5th letter. The left side just represents the length, and the right side represents the starting index. The left side represents... So this is this big buffer. This is just this big, long list of bytes where we have the length of the word, and then the message. It's just like the little format that we've chosen to do is we first write down the length, how many letters are in the message, and then we write down the message. And then here we keep track of where they start. I think a pop will make more sense here, because pushing feels very arbitrary when you don't know how a pop works. Let's pop something. Let's pop something from our little queue. Boom. Step 1, we look at our little map. We want to get the 0th message because our read count is 0. Our read count is 0. We want the 0th message. We look at the map. We know that the 0th message starts at byte 0, right here at the very, 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 very beginning of this little file. We know that our message is 3 letters long, so we read the next 3 letters. We've looked at index 0. We've gone here. We see that it's 3 letters. We read the next 3 letters. Great. Increment the read count. We finish reading number 0. Why do you write down the length instead of diffing from the list of indexes? Because you might be reading the last value, and there won't be a next value to diff on. And it's a dangerous game to play. This keeps it very simple, and there's a lot of networking things that need the length of it anyways. It's an easy, well-known format for a lot of use cases. Hopefully that makes sense. And then we increment the read count. We read the 0th message. We are now on the 1st message. Cool. We've got our little push. We got our little pop. We have a message queue. This is it. We've done a message queue. Now, unfortunately, we have to make sure it works in parallel, because that's the whole bit of it. How do you make this work in parallel? I have a technique for parallelizing things that I think a lot of people use intuitively, but don't really talk about how it works. For parallelizing things, where I do a slow thread and 1,000 fast ones. I use a methodology called a slow thread and 1,000 fast ones, where essentially you walk through your head where one thread is doing one operation and then stops. Like, it's just tired. You just have one CPU core that's really tired. It's going to do one operation, and then another thread will come in and do a ton of operations. One core is really slow, one core is really fast. So let's walk through our little example. Pop maxi into the stack. I'm now #1 in the pop chart. Hell yeah. Hell yeah. Let's go through a little example. We have our slow thread. That's popping. We're getting the byte offset. We're getting the read count. So our first thread, our little slow thread, has read the read count and it got 0. It got the number 0. We're reading the 0th message. The slow thread is going to read the 0th message. Yay! Except now it gives up. Now the slow thread just goes, I'm tired. We're taking a little snooze. We're doing a little snooze fest. Fast thread comes in. It's going to do every single operation before the next thread, before the slow thread gets to the next one. So it's going to read the 0th message, do the whole thing, pop ABC, and then increment the read count. You might already see an issue here. Our slow thread has just figured out that it needs to read the 0th message, and then the fast thread has already read it. Things are slowly starting to go wrong. We get the next instruction. We're reading the next, few bytes. We're getting our ABC. We're doing the things. Fast one comes back in. It's reading the first message already. It read the 0th one. It's reading the first message. Our slow thread had still not finished reading the 0th one. We have now popped ABC. We've now popped AS. We've popped the 0th message and the first message, and our read count is now 2. And then we do the third message, the third instruction on the slow thread, rather, where we increment the read count to 3. So we've popped ABC, the 0th message. We've popped AS, the first message. We popped ABC again, the 0th message, and we're now at read count 3, so we've lost a message somewhere. We've duplicated messages, we've lost messages. It's all gone wrong. It's all gone wrong, and it's all because of this get, and then we read, and then we increment, and this is dangerous. This is a danger zone. This is bad, because multiple threads can come in and get the same read count. Multiple threads can come in. If you had infinite threads and you got super unlucky, each one would read the number 0, and then they would all try to read the same value. It's a mess. It is a mess. For good measure, we're doing another fast pop. It's all gone wrong. We've totally missed a message somewhere. Great. How do we fix this? The magic of atomic fetch add. You don't need to know what atomics are. I can do a whole nother lecture on atomics because I think atomics are really cool. For now, we can just assume all operations are atomic. What's special about fetch add? Fetch add is a very cool instruction that in one operation fetches the previous value and adds to it. It makes sense. It's called fetch add. So if we have a starting value of 0 and we call fetch add 1, it's going to return 0 because that was the previous value and add 1 to it. If we call it again, it's going to return 1 because that was the previous value and then add 1 to it. Cool. Beautiful instruction. Why is it important? Because it solves this issue. It solves this issue where if two separate processes are trying to read and increment the same number, you won't have this, both of them read 0, but then they both increment, so it's now 2. So we've somehow lost the number somewhere. It's all a mess. We can do that in one operation with a fetch add. It's atomic and it's nice and it's beautiful. So how does this fix the problem? Let's stick it in. Let's replace our get with a fetch add. Instead of getting the byte offset, we're going to fetch add read count. We're going to simultaneously get the number 0, because that's our current read count, and add 1 to it. So our slow thread does a fetch add. We've gotten the number 0, and we've added 1 to it. Our read count is now 1. Fast thread comes in. It's going to do another fetch add. It's going to read the first message, not the 0th message, and it's going to pop AS. It's going to pop the first message, also with a fetch add. Boom, we keep moving on. We read the next length bytes. We're going to call that a pop. We've now popped the first and the 0th message. So they're out of order because one of the processes happened to be really slow, but it doesn't matter. It doesn't matter because now we've gotten all the messages. For a little third time's the charm, pop another one. It all works out. It all works out. We've gotten all the messages. They're a little out of order, but by replacing our get with a fetch add, all of a sudden, bada bing, bada boom, one instruction does a whole lot and we're safe. Let's talk about pushing. I think popping. So this one is unfortunately I didn't have time to do graphics for, but hopefully pushing will make popping more clear because I have graphics now. Oh, in good measure, one more pop. Why not? Let's try pushing beef. Let's try pushing beef again. Except now we're going to do slow and fast. And I think this is the one where it all goes wrong. We're going to go through the slow thread first. We write the message length. We've seen this before. We write 4. Beef is 4 letters wrong. 4 letters long. We write down the number 4. Great. Lovely jubbly. Fast thread comes in. It's going to do the whole shebang. It's going to push dog. It's going to push the word dog. It's going to write the message length. It's going to copy the message. It's going to add the index to map. And then it's going to update the write count and index. All of a sudden, it's overwritten the data with 3 dog, because dog has 3 letters. It's updated the map because it starts at the 13th byte. It's updated the write count. We're now on the 5th number, 17th byte, yada, yada, yada. And now the slow thread copies the message. Oh no. Oh no. We got a 3. We got a B. We're writing out of bounds here. It's all gone wrong. It's over. It's over. Nothing makes sense anymore. None of the data makes any sense. We've lost things, we've gained things. It's all corrupted. Incredible. Another fast push comes in. It's so over. We got a 3, we got a B, we got a dog. Data's corrupted. It's gone. This is horrible. This is horrible. How do we fix this? Another atomic fetch add? In one operation, we do a couple magic, we do a little trickery, we do a little black magic, and then bada bing, it works out. Not quite. Not quite. Where did the cat go? Exactly. It got overwritten. Not quite. We can't do this anymore. Why? We have 2 numbers. We can only do 1 number at a time. Because if we have 2 numbers, that's still 2 operations. Even if it's atomic, that's still 2 operations. We need to, one of them's going to happen before the other. We're going to get in a bit of a mess. We can only do 1 number at a time. Which one do we do first? Double the number, double the trouble. All of a sudden, we have the exact same issue. I'm not going to run through the example, but we can't do our little magic. We can't do the atomic fetch add. So how do we solve this? Which one do we do first? How do we do this cleanly? Actually, I lied. We just do both. How do we do both? We do magic. We do bit magic. This is unfortunately where it actually gets a little bit more complicated. Because how do you do this? You need to somehow use 1 number to represent 2 different numbers. And in programming, we usually call this an onion. Some people prefer to call it a union, but I'm not about that communist life. Therefore, they're onions. How do you represent two different numbers with one number? You split it up. You split it up, and we got to stare at some binary, but you can imagine it's not binary. You split it up where you say, okay, let's just say the first half of the number is one number, and the second half is another number. All of a sudden, we're just splitting our number in half. Boom. We're saying the left half is this thing, and the right half is this thing. And we can do a bunch of bit magic to make sure that we never get the two confused. So how does this fix our problem? We can do, with a bunch of bit magic, a fetch add that increments both the index and the write count. We're going to increment the bytes and the count at the exact same time with bit magic. For example, if we are starting with an index of 0010 or decimal 2, we're writing to byte 2, and we have one message. We can do a little bit of magic here where we're adding a byte value of 3, 0011, and we're incrementing the count by 1. You can do some bitwise magic over here to understand how that works. And in one operation, we're incrementing both values. Very cool. You can rename that operation as a union fetch add. It'll take a tuple, it'll return a tuple. It's also going to return both numbers in one operation. So we've done a lot of stuff in one atomic operation. We're getting both numbers back, and we're incrementing both numbers. Great. Now we can do the exact same trick and replace it with a union fetch add. So step 1, our slow thread does a union fetch add. It's going to increment the write count by 1 because we're writing one message. So it's going to increment the write count by 1. Maxi with glasses. It's Professor Maxi. Thank you, Nora. And we're going to increment the byte index by the length of the message, aka 5, because it's 4 letters in beef plus the 1 for the number. It doesn't matter. We're incrementing the length, the byte index, and the write count exact same time, while simultaneously getting the previous values, which are 4 and 13 respectively. We've written 4 messages, and we're at byte number 13. Boom! Fast thread comes in to write dog. It's doing the exact same thing. It's going to do a union fetch add, except now it's going to get the numbers 5 and 18 before we've even written the message. Before we even wrote the message beef, we're getting the values 5 and 18 preemptively, assuming that that message already exists. We're writing the message, we're copying the message, we're doing the whole thing. Nice little example where we have these zeros. We have a bunch of these zeros where this empty message is. We're going to write to it in the future, but we've already kind of reserved that space. By doing that fetch add in the beginning, we've sort of reserved that space. We say, we're going to be writing here in a second here. We'll take our time, it doesn't matter, but we've already reserved that space. And the fast thread comes in, ignores those numbers, and does the 3, because dog has 3 letters, and then it writes dog, is updating the write count, updating the map, it's doing the whole thing. It's just leaving this number 0, for now, because we're still working on it. Julio. Slow thread's back. Slow thread is back. And it's going to write the message length. It's going to copy the message. I'm just going to say that's one instruction because you get the idea. Little example. We finally filled out our little zeros. Gotten our 4, gotten our beef. Great. This is still 0. We haven't updated the mapping yet. We'll get to it. Fast thread comes back. Pushes dog. Pushes another dog. Got 2 dogs now. Everything's working out. This mapping is still 0, but we don't care. We don't care. It's still 0. We still don't care because everything's working out beautifully and we know it'll work out eventually. Now we add the index to map. We add the index to map. We've updated it to 13 and everything has gone smoothly. Incredible, right? It's all lock free. We're just doing atomic magic. We're doing atomic magic with the promise that if we increment a number and we get to this point where we have a bunch of zeros somewhere, our thread will eventually write data there. Like, we have a guarantee that eventually there will be data there. It might take 1,000 years if your CPU really fucking blows, but it'll eventually get there. And it's just reserving that little space. And I think a good example that I've heard from someone smart is, like, we have this piece of paper. We have this piece of paper, and we're all trying to write to it at the same time. Like, everyone in chat is trying to write to the same paper. Oh my god, packets. Oh my god, packets. Oh my packets. No KB0? Did I just get saved? How much of the lecture have we missed? Are we back? You were gonna say something, but you didn't want to distract me? Oh no, internet! Oh no, internet! Alright, we'll let it stabilize a little bit. Can I get a from 1 to 5? Ads are about to start here. From 1 to 5, I'll wait on the ads. How lost in the sauce are we? 5 is like we're swimming in it. 5 is like we're swimming in it. 1 is like I'm following. I'm on board. I am on board every single step of the way. One. Oh my god, we're so back? We're so back. We got 2 1s. That's all I need. That's the confidence boost I needed. 1.99, you have ADHD? It's okay, we truncate that to 1. What was the scale? 1 is crystal clear, 5 is you're swimming in the sauce. 5 is you're lost in the sauce. Sorry about the ants. We'll get back to the lecture after the ads. 2? 2. Okay. Understandable. I think there are certain parts of this that I have to gloss over, because otherwise this can get really boring. And if we have interest for this, I can go way more in depth on will this be on YouTube as well? I'll rewatch and edit it a little bit. And we'll see. Honestly, this is my first attempt. And I'm a certified waffler. Thanks, music. You're lost in the sauce because you weren't here. That's okay. Okay. The VOD will be on YouTube anyways, and there will be a highlight. But I don't know if I'll do an actual edited VOD. We'll see. Hi, Spotify. You have your sick excuse? Fine. I'll accept it. One thing we could do before moving forward here is actually looking at the code. Because everything I've yapped about here is not random. This is actually the implementation of the disk multi-producer, multi-consumer. And we can even see the parts of it here. We have our count right index. This is our union. This is our onion. It's keeping track of the right index and the count simultaneously. We have our union fetch add. That's doing a bunch of bitwise magic to simultaneously add the byte value, the byte right index, plus 1 for the message count. We're incrementing the messages by 1. We have our little buffer, which is like that raw table. We can even look at the little bit of our little push operation, wherever that push is. Push, 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 push. Where we're writing the length of the message and then the message itself. It's all actually this is the entire implementation. Everything I'm talking about is the implementation that I've done. There's certain other magical things that have to be added that unfortunately don't fit in this lecture. But hopefully it makes this implementation make a lot more sense. What's the difference between message queue and pub subby? A message queue is a pub sub, but not the other way around. Can be a pub sub. Pub subs share messages, message queues take messages. Pub sub has MQ. Boop, 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 boop. Like if we look at the very beginning, the biggest difference between a message queue and a pub sub is in a message queue, if I'm reading this value, this read index is global. This read index is shared between every single consumer. So if one person reads from this message queue, they get A. And then if a totally unrelated second person reads from the same message queue, they're going to get B. They're not going to reread A. Message queues have messages taken from them. Now, the only thing you really need to change to make it a pub sub is to make this read index not shared amongst consumers. They're just internal to every single consumer or person. So like a person comes in, they can read all the messages. Another person can come in, they'll read all of the same messages without taking any from any other consumer. That's why I'm like, I think you can kind of always turn one into the other depending on what you need. Yeah. I see. Hopefully that makes sense. That's why Franz has consumer groups, which is a way where you can kind of strike a balance between message queues and pub subs. Where you can say, like, if you share, like, you can have these shared indexes, but they're in like little circles. You can subscribe to be like, oh, I'm part of, the maxi family, where we're all going to take messages from one another, but not from the Lillian family, which is going to have its own totally separate read index. They're still reading the same messages, but it depends on which family you're a part of, where you take messages, which ones are shared, which ones aren't. MQ, one message to one consumer. PubSub, one message to end consumers. Yes, that's correct. Totally correct, yes. And you can sort of always turn one into the other. Because a message queue can just clone messages, right? Or a PubSub, can just have one consumer, right? Like, they're definitely interchangeable. It's just one is always optimized for another, for a specific use case. Except for Franz. A lot of the beauty with what we're doing here is what we can do, a nice little magic trick here, is that this is all in pretend memory. And if we're reading a value, what it means to read a value is to return a pointer to this byte. If we're reading ABC, we're going to return a pointer that says, hey, read from this byte. Whoops. Read from this byte and read only 3, 0, 1, 2, whatever, 3 bytes. Read the next 3 bytes. So we're returning what in Rust it is called a slice, but it's just a pointer with a length of 3, which means it's 0 copy. We never copy this message. We're just passing around the pointer. And if you need to read this message, you can read it directly from this page. So it's 0 copy, which means that I can switch between a message queue and a pub sub super easily. And it'll never clone messages. So it's actually exactly as efficient for one or the other. Cool stuff. Cool stuff. Next question. Uh-oh. We've run out of size. We filled the page. It's a file. It's a file. We filled the file. Our file has, I don't know, 100 characters. We've written all 100. What do we do now? What do we do now? It's so over. And unfortunately, that's where I have to leave off. This is for lecture 2. I didn't think we'd blaze through this that quickly. But this is for lecture 2, and this is getting into a little bit more magic. There's going to be one more magical thing, but this is the last bit. And then you almost understand Franz, but this is the Franz implementation. Hopefully that was a little fun. Short little segment. The rest of this is me role-playing a teacher while yapping. Cliffhanger? We'll see. I didn't want to make it too long. I don't want to make it too long. I know like 80% of us have ADHD. Because I feel like there's a lot there. There's a lot there. We got some atomics, we got some fetch add operations, we got some unions. I think unions are a very magical thing. They are inherently unsafe. Rust does not like you using unions. There's a lot of trust me bro in this implementation. This is not like a super recommended way to do this, and if you were doing it in memory, you would not do it like this. If you didn't have to make this, because a lot of the issue that we're running into is that we have to do it on a file, which means all of our quote unquote memory is sequential. We have to write all of our messages sequential. We don't have any like magical pointers. We can't just point to another data structure somewhere, because that's a lot of the way that you would do this. You would just have a vector of pointers. Right. And you made a pub sub. Well done. Now you just add a few atomics here and there, and then you're good. A lot of the issues that we run into is just keeping everything sequential, which is not fun. Just in time to go to sleep. I'd never hold you. I'd never hold you too long. If we do another lecture, there's 2 routes we can go. There's 2 routes we can go depending on what we enjoy. I can talk a lot more about computer science, because we didn't touch anything about computer science. I can go very, very deep into the computer science route, or rather the computer engineering route of like, what are atomics? Why are they useful? Why do they exist? We can talk about memory management. We can talk about memory management at the application level versus the kernel level versus the physical level. I think that's fun. That's a lot of the stuff that I would like to yap about. we can talk a little bit more about parallel design. So basically, I'm asking, do we want to go into the computer engineering route, or do we want to go into the design route? Or both? Or never do another lecture again, Maxi? Keep Sundays lazy Sunday. You'd love the CS part. I think CS would be more fun. I think CS would be more fun. What I would like to do, I don't want to lecture for long periods of time. So what my plan was in my head is I want to have a 30-minute lecture on, like, if we're talking about memory, we would have a 30-minute lecture on, like, the basics of memory, and then I'll take a short break, and then I'll do a 30-minute lecture on advanced memory that I probably I know a lot of us aren't I guess classically taught in computer science. You're a big yapper, so you can just kind of listen. Awesome. I know a lot of us are, like, not computer science by training. There's a lot of cool stuff that I think a lot of more advanced things that I think kind of get lost in the programming community because they're just not super useful to know. They're not super useful to know, but they are very, very cool. So I'd love to split it into 30 minutes on, like, basic stuff. 30 minutes of basic stuff that a lot of you probably know, but maybe we'll get a few more newer programmers in the community, where I'll talk about things like, what's a stack? What's the difference between a stack and a heap? How does the stack work? How does the heap work? What is virtual memory? And then I think we can split off and after do another lecture about what is the MMU? How does the CPU like how do page tables work? Things like that. Cache coherence. Can talk about cache coherence. I don't know. I'm just kind of thinking out loud. I'm just kind of thinking out loud. But yeah, thanks for joining the class, everybody. We're keeping it nice and short today. All I have left is kind of just lazy Sunday vibes again. Wow, all that running late. All that running late. All right, here's the plan. Leak code Sunday? Absolutely not. Absolutely not. Absolutely no leak code Sunday. We're gonna switch to official lazy Sunday time. Hopefully that was a little fun. We'll see. We're gonna go to boom, bing, lazy Sunday. Ah, the one time you wouldn't have the energy to flex on me. I'm so good. I'm so good. I've done enough leak code. Bugging, Rust projects. So Controllo kind of mentioned that they understand why Franz works the way it does now, and I don't know if that was a bit or not, but I do think that the kind of magical part of Franz that I've had a hard time explaining is messages get lost. Franz messages get lost at very weird times. From kind of an outsider's perspective, Franz just loses messages whenever the hell it feels like. You shut down fronts, messages are gone. But I think now we kind of have a better understanding of why does it lose messages? And it has a lot to do with the way I've done these fetch ads. Let me pull up this example. A lot of the question becomes, what do you do when you've read all the messages? Well, you know you've read the messages because the read count is equal to the write count. That's pretty obvious. If the read count is equal to the write count, if our read count hits 4 and our write count is 4, we know we don't have any new messages. You can do some cool atomic weight stuff to just sleep the thread until there is a new message. Great. Lovely jubbly. The issue becomes that the way that we get our read count is by doing a fetch add. So we fetch add, like imagine our read count is at 4. And we do a fetch add. And we set our read count. Oops, not that. Give me a new. Give me a new. Our read count is 4. We do our little fetch add. How do people write with their mouse? Which sets our read count to 5. But we read the number 4. Because it fetches the previous value and then it adds 1 to the current value. So our RC equals 5, but we've read the number 4. And now we see that, 4 is equal to our write count of 4 messages. And we wait. We wait for the next message. We know we've read all the messages, so we just wait. Great. Incredible. Yeah, that's all good and all, as long as you never ever exit or crash the program, which is not a reasonable thing. It's not a reasonable thing. Programs crash. You need to update things, you need to upgrade things, you need to close things. There's no nice way for me to handle the situation where we're waiting here. We're waiting for a new value, and then we kill the program. Because now our read count is 5. Our write count is still 4. Even if we restart the server, we're now in a new state. Our read count is 5. Our write count is 4. So if a new message comes in, our write count is now 5, and our read count is still 5, we've lost a message. We've lost a message because we did our little fetch add magic, and we don't have a nice way of decrementing it. What you can sort of do is say, okay, well, we assume that, if we're shutting down the server, maybe we should just decrement the read count for every waiter. Because the next issue becomes, okay, what if we're at 4 and we have 4 messages and we have like 16 readers? What if we have 16 readers that all do a fetch add? They're all in the same group. They're all sharing messages, so they all have to read different messages. We have 16 times fetch add. Each one of them is going to get a different one. They'll get 5, 6, 7. They'll all get a different value. It all works as intended, but now they're all waiting for 16 more messages, and our read count is now 20. and then we kill the process. We're losing a message for every single reader. It's dumb. It's bad. It's not good. The issue is that for every way you have of fixing this is not instead of doing a fetch add, you could do a compare exchange. I don't see, well, because then the reads don't work. Because I mean, so basically, there are ways of fixing it. There are ways of fixing it, but they all involve some form of locking. Um, which is bad from my perspective because I'm going for speed. And basically, the compromise that I've made is I think it's fine. I think it's fine to just lose messages because what we're going for is speed and not necessarily, perfection here. And I'm still thinking of a way to maybe fix this up a little, but I'm not sure. I'm not sure. But that is the issue. That is why Franz randomly, quote unquote, loses messages. It loses messages on every restart for every receiver. I think the way I'm probably going to solve it is to do a very fancy cleanup. Because it's easy for us to keep track of like, why is that so big? The number of consumers, the number of it's easy for us to keep track of consumers, the topics. Like there's a lot of data that we can track, and we can say if we get a signal to stop, we're told to stop. We can halt any new messages. No new messages. We can wait for all of our consumers to sort of stabilize, as in reach that waiting state where all of them are just stuck waiting them with that weird fetch add. So any consumer that has a message has read it. We just wait for everything to stabilize a little bit. And then we do a long process where we kill consumers, we do compare exchange instructions, and we try to roll back all of the fetch add instructions into a desired state. This is slow. This whole thing is really slow. That's I can do better. Here we go. This whole thing is really slow. You need to stop new messages. You need to wait for stabilization. And I think that's literally you just wait a second. Like you wait a second for the computer to just do its thing. There's no way to confirm this. There's no way for me to like really know what this means. I'm just gonna kind of wait. And then this rollback instruction. That's gonna be doing a lot of comparing to just say like, okay, we have this many consumers open, this many are waiting. We can do like send them a message to get them out of the loop. They'll like try and do a subtraction and make sure that like we're not duplicating any data anywhere. But I think this is fine. Because we're shutting down the server. That can be a fucking minute if we really wanted it to be. So I'm probably going to do something along these lines. The issue has been that I'm kind of burnt out from Franz. and I am too lazy to think of the logic on how to do this, but I do think it's going to be something along these lines. Check. Ew, a fly. Check. Ooh. Oh, crit is great. I don't know. What other design things can I talk about? There's a few quirks that come about from the way that I've designed things that maybe if you paid close attention, you'll realize it's all files. It's all memory mapped files. They're static size. I can't grow them. I guess I can shrink them, but you can't grow them. You can't do anything super like crazy. Um so the question is, how big do you make it? And Rust doesn't even allow like tail unsized tails, whatever it's called, opaque tails. Yeah, Rust doesn't really allow opaque tails. It does in very, very specific circumstances. Unfortunately, this is not one of those very, very specific circumstances. So I have to determine a lot of this stuff at compile time. And the question becomes, okay, so how big do you make each of these things? How big do you make this page? How many bytes should this be? How big do you make this thing that's keeping like this map that's keeping track of the messages? Because basically, the size of this is the number of messages that you have in a page, and the size of this is the total size of bytes for all those messages, which you can kind of simplify as you need to know how big your average message is. If you know how big your average message is, you can kind of figure out, okay, well, let's assume we have like 16,000 messages per page. You can do a little math to figure out the size of the bytes, how big you need this to be. And that becomes one of the multi-producer, multi-consumer's biggest quirks, is that you just guess that. You guess that at compile time. There's no nice way of doing it. If we had opaque tails, you would be able to do a lot of math at runtime to figure this out, which I think would be fucking awesome. That's my end goal for this. If Rust ever allows it, I'll totally do that, where it's doing math at runtime to figure out the size of these pages. That would be so fucking cool, but you can't do that right now. So there's a lot of these consts that are pulled from environment variables to guess how big your messages are. And this is our index map, which is literally this. This is the index map with the max messages per page. And this is our buffer with max bytes per page, which is literally max messages multiplied by the expected message size. So that's kind of the final little quirk. I'd say there are two big quirks to the disk multi-producer multi-consumer that kind of fall out of the way I designed it. Although this one is fixable. I guess they're both fixable. Just with time and effort. It is really fucking fast though. I think that's the part that I like the most, because you know I'm just here for fun. I'm just here for fun. I love doing things like this. It's really fast. It's really fast. It writes at 1 gigabyte per second. Gigabyte per second. Sorry, it reads at 1 gigabyte per second. It writes at about 500 megabytes per second. Very fast. It does have kind of, well, a lot of this, a lot of the way multi-threading works is it's fast when you do it sequentially, but then for every thread you add, it's not going to get that much faster. So for every thread you add, it'll be like maybe 10% faster. This has to do with a lot of like memory coherence, and also because this is disk mapped, and the operating system has to dump these pages back onto disk, and all of this really slows down with the more threads you have. It'll still get incrementally faster, but not linearly. So Kafka kind of taking the dub on that one, not gonna lie. Kafka does have linear speed increase. Which is kind of crazy. Don't save this. Thank you very much. And that's all, folks. Let me see if there was anything I can quickly fix on Disk and PMC. I do really like my lazy Sunday coding, but I am kind of exhausted if it didn't come across. Really was not having it this morning. It's clients. Runs. Issues. Oh, I guess I could implement some of this. This I did. Flag for mini fronds. This is now determined at compile time. There are loops in the code. False. This I could do. Could maybe implement option to consume from beginning or end. That'd be cool. Already up to date. Cool. I think this might not even be that bad. I was implementing a ton of shit before. Oh wait, did I never finish implementing a lot of this stuff? Oh no. I was really trying to like figure out that first problem of making sure we don't wait for new messages if they're not there. And I was in the middle of doing that, and then I didn't fix it, and now I don't remember where I am. Oh no. Get the group count. Get the total count. Wait on the total count. Ah, yes. I remember. I thought there would be one way that I could fix this was if before you do a fetch add, you get the read count, and if it equals the write count, you wait the thread. You say, wake me up when this is no longer equal, and then the writer will wake up one thread, which will make sure that you never have any contention, so that if one message comes in and two threads are waiting, you only wake up one thread. And this works fine if you don't have consumer groups, because you don't know if the threads that are waiting are trying to get the same message or different messages. If they're getting different messages, then you only need to wake up one of them. If they're getting the same message, you need to wake up both of them, and it gets really complicated. And this is like a Bronze V3. This is like I have to rewrite the entire implementation for it to work like this. That was one thought that crossed my mind, which is what I was trying to implement. And then I had that realization and I was like, oh, that's why I didn't do that. Oopsie daisy. Ooh, I also need a way to initialize pages. You know what? It's lazy Sunday. We're doing code cleanup. We're just gonna keep doing code cleanup. Hmm. Let me get rid of all this garbage. I feel like I need a git reset here. I guess I never pushed this. I don't think I ever pushed this. We're just gonna do a git reset. There were a couple of things I wanted to do. The first thing I wanted to do is I have this get with timeout function, uh, which just doesn't block infinitely. It has a little timeout, but I've never used it, and I don't think it's a very useful function because it still runs into the same issues. So I'm just not gonna have this. And what that gets us is that we don't have to use the timeout operation is only supported on Linux, which kind of fucking blows. Which means I can actually run this on my Mac now, which has been annoying for debugging. Hi Timmy. You missed the lecture. Missed the lecture, Timmy. This does mean that I have to do the atomic weight crate. The weight crate. But I don't need this. I don't even need this outside of dev? Yeah. Yeah. It's just gonna make it more cross platform. Maybe it'll even work on Windows. Who knows? I do famously say that none of my software works on Windows, but maybe this time it will. Heck, what lecture? Oh, it's so over, Timmy. Was it about burgers? It was about subs. Mm-mm. Hmm. Or nuggets? It was about subs. Is this all fine? Okay, apparently this is all fine. There it is. I need to fix all of this stuff because this is now an atomic weight. Atomic. Wait, what? Self, store U32, and then atomic wake. Atomic weight wake. Atomic weight wake all. And this takes a reference. You like Subway? I always think I like Subway and then I get it and I'm like this is not what I wanted. Every time I walk past this, I don't know, how do they make that Subway smell? Is that like a thing? Is that like a thing? How does Subway smell so good and then it kind of tastes like Well, kind of tastes like Subway. Kind of expensive. It's also expensive. It's like both expensive and like kind of not. I don't know. It's fine. Like, don't get me wrong. I am not a Subway hater. I'm very much not a Subway hater. But it's also like, I don't know. You don't get your bang for your buck. That makes sense? I want a place that's value. I don't want to pay mid dollars for bad food. I'm okay with paying I'm okay with like paying very little for bad food. That always feels good. That makes me feel good. But paying mid money for bad food is not it. Maxi, what are you talking about? I don't know. Just yapping. I also recently found out that atomic weight doesn't doesn't have spurious wake ups. It'll only wake up if the value changes, which is very cool. I didn't know that. Which means we don't need this loop and I can fix my code. Match on self. If it's I, you return I. If it's 0, you do this stuff. Did I ever boast in Discord that I went live? Is it so over? It's so over. Mm, is this fine? I think this is fine. That. That. Okay. If it's 0, we wait for it to not be 0, and then we return acquire, otherwise we return I. If it's greater, we do this little wake up thing that I got going on. Wake all. That's a reference. What is Discord? It's a mess. It's like a little messaging platform, I guess. You should join it. We do cool stuff and we yap in there. You're in the Discord. You're doing a bit. You're doing a bit and my brain isn't on enough to recognize that. It's so over. Maybe this is Maxi's shut up and code era. Ever ever since toting. Ever since toting called me out. Ever since toting called us out. It's time for my shut up and code era. At least I don't have a text editor open. When I yap, it's closed. Toting straight up calling you out. I make things. I make things. You've been known to yap on occasion? There's nothing wrong with a yap or two. I make things. Look at the cool thing I made. Look at the cool thing I made. Just because I'm a certified yapper doesn't mean I'm also not making things. Honestly, kind of just a skill diff. Kind of just a skill diff where I gotta do both. Started learning Rust yesterday. How's that going for you? Obviously perfect, and you've run into 0 issues? Is this fine? Is this fine? Obviously perfect, and you've run into 0 issues? Nice. Nice. I wanted to make a function to actually load the page count. But I need a smart way of doing this. You learned how to print hello world? Is that a bit? Like like this? Is that how far you've gotten? Or yes. Okay, cool. I'm glad we're on the same page. I'm glad we're on the same page. And mm, 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 mm. Mm. Yeah. Reader. Dot. Hold on. Hold on. I can make this work. Result. Usize. Standard IO error. We read the dir. This is an iterator, I believe. The iterator returns an iterator over the entries within a director. The iterator will yield results of IO result dir entry. So I need to iter over this where I filter. Is there a built-in way of filtering filter map, I guess? I want to filter map unwrap. Is there like a nice way of doing this? Filter map unwrap. Filter map. The return iter yields only the values for which the supplied closure returns some. So I want to do e dot okay. And then dot count. And then dot okay. The question mark only be used in a method that returns result or option. Where did my result or option go? Result. Usize. Standard. IO. Error. Damn, that was it? Only thing I need to add is filter. Filter. This doesn't matter yet, but just in case, e dot file type. What does file type give me? reader. If let okay file type equals entry dot file type. File type. Hmm. Hmm. FS. Reader. Gives you a reader, which gives you a dir entry. Dir entry. File type. What does this mean? Is this not the file extension? What is a file type? Don't make me run this example. Normal file symlink or block device. That makes so much more sense. That makes so much more sense. All right, cool. I guess I'm going to do path and then get file extension, get the extension. Returns an option OS stir. Sure. I'll go with this. File name dot extension. Oh, wait. I get an OS string? Oh, I want file path? Dot path dot extension is equal to some. Now let's make a cool little file extension. We making our file extension for mpmc dot mpmc dot franz dot fz dot maxi. We'll do dot data for now. Not super unique, and I probably should make it more unique, but oh well. Data page extension. Can I make this an OS stir? I don't think it's gonna let me do this. Portrait acronyms that coincide with your name is mandatory for hobby projects. Very true. Very true. I'm just wondering how I differentiate my things from normal files. I guess I could just do a whole file name. Returns the I think file name is probably better. But it includes the extension. What do I want? I want file stem. I want file stem. That's what I want. I want file stem. I want a file stem that we will call dp.data.maxi. I don't know. I don't know. Why not? Why not? Why the hell not? File stem is equal to sum data page file stem. Close that out. Boom. Now I need to make sure files actually have this name. What? Expected. Fuck, it's not gonna let me do this. Can I call it into? Please let me just into. No. No. Oh, a stir. New. This feels silly. This feels silly, but oh well. Oh well. I'm just double checking my logic here is right because I'm wondering if it's looking for the actual number of max pages or the ones that exist. Map cell new name total page count to string. I need both the total page count and the max page. I need both of these things. And they're not the same. It's going to be our load max page, which is going to do the same thing, except instead of dot count, we need to do some fancy map stuff where E returns. Actually, we'll do a filter map. Filter map. E returns E dot path dot extension, which is an OS stir that we then map to to stir lossy. Oh no. Oh boy, oh boy. To oh, I'm lost in the sauce. Oh my god. Oh my god. I'm lost in the iterator sauce. Unwrapper 0. Oh my god, there's no way that worked. There's no way that worked. There's no way that worked. No method named parse for an option. It's in the wrong place. I need a map on this to do an s.parse. Then close that there. Come on. Expected type usize found option result. Is this, am I doing this wrong? Should this not be map? This should be and then? Returns none if the option is none, otherwise calls f with the wrapped value and returns the result as opposed to map. Why do I still not know the difference between these? Consider using a result expect. Could this be an and then as well? Expected option found result. Expected option. So this needs to be a map? Okay. Damn, the Rust devs better be proud of me for this one. We filter map on OK values. We filter if it's not equal to the data page file stem. We filter map if the extension can be parsed as a number. Oh, this doesn't even have to be unwrap or. This can just be dot OK. Right? Why? Expected usize found option. Then? You get the extension. You see if you can parse it to a string. If you can parse it to a string, you try to parse the number out of it. You get the max number, and then you unwrap or 0. Woof. Okay. I don't think this is going to work on the first try, but I am hopeful. Yay. Okay, but now the actual logic. Maximum page count and the total page count. So I want to load all the pages that exist, which is going to be everything from max page count minus is there like a maximum number of pages that I had somewhere? Nope. Cool. Oh, you said it. Oh, max data pages here. Hmm. We'll do a saturating sub of usize max, which is a little silly, but I'll just change that in the future. Famous last words. all the way to Hmm. No, it's not usize max. It's the total pages. Maximum page count minus this total page all the way to the max page count. Okay, this makes more sense to me. So this is like if we have pages 5, 6, 7. We want to load seven minus 3 to 7. This is wrong. This needs to be total page count plus 1. Okay, this looks bizarre, but I think it's right. You do have to get the file name right, though. Path, join on our file stem. And then that extension? Set extension to I dot as a string. So this is gonna look something like, well, if I ever make it work. With extension? With extension. With extension I. So this is gonna look something along the lines of dp dot data dot maxi dot, you know, whatever number dot 0. Sure, why not? Why the hell not? This is fine. Now I just need to make sure the actual creation does the same exact thing. Oh no. This is gonna be one of those things where I forgot to change it in one place and everything's gonna break. Data page file stem with extension. Oh my lord. Your favorite sarcastic project title is for your wheeled robot project, which you called CART? C-A-R-T? I have a new flag in the back? I don't think so. I have a typo. There you go. Contrived acronym robot title? That feels a little forced. Contrived acronym? That's awesome. I think I just need to find every place that I did a format. If I called format somewhere, that one's fine. That one's fine. You know what? Just run cargo tests and see what happens. Oh, cool. 4 failed. A global default trace dispatcher has already been set. Oh, I can only run one at a time. We'll try sequential. Out of bounds access. Oh, cool. Out of bounds access on line 129. Hmm. Oh, it's definitely a typo somewhere. Data page count modulo max DPS. Okay, what happens if this is all 0? If this is all 0, it's all broken. Because our total page count is 0. Our max page count is 0. We're iterating over 1 to 0. It's so broken. It's so broken. What? Does it even work if it's 1? We're iterating from 1 to 1? 1 to 1 is fine. So the maximum page count just can't be 0? Or the total page count? If the total page count is 0, this whole thing doesn't make sense. That's the issue. Ah. If max page count less than 1, max page count equals 1? No, I know. I just usually when you have some off by 1 shenanigans like this, there's just a better way of doing it, and I feel like I'm being an idiot. Because I'm already doing this weird +1 here. That doesn't make any sense. Why did I add this +1? If it's 6 and doing 5 to 7, 7 minus 5. Uh. There's just really contrived logic going on here. I mean, unironically, I think if the total count is 0, you make the total count 1. This is so stupid. Boom. Fixed. You set it to the maximum of itself and won. Incredible. Because then if it's 0, it still makes no fucking sense. Oh, cool. Oh, cool. Does that make any sense? Does this break stuff? I don't think this breaks stuff. Hooray for hacky fix. Alright, now does it work? Still no. Still doesn't work. Why? Because now we're going from 1 to 1 and I'm getting an index of 0. Can you change the page count like that? Easily. You missed the lecture. You missed the lecture, but yeah, I totally can. I think there's just a special case when you don't have any pages, you need to make them up. I feel like I'm just being silly though. Lecture put you straight to bed? That's good. That's the point of it. I should just do this, right? Does this fix all my issues? If it's 0, we do 0 and 0, we iterate to 0. Yeah. Yeah, I just needed to do that. I think it was just backwards. I think it was just backwards. Hold on. Why my brain's not working right now. Yeah, it's fixed. It's fixed. It's fine. Boom. Perfect. Try that in release mode. What speeds are we getting? Not, I'm sorry, 9 gigabytes a second? Is that right? 9 gigabytes? I was way off on the numbers I was saying in the lecture. I'm 9 times faster than what I thought it was. That's faster than Kafka? That's like, I think that's 100 times faster than Kafka, yeah. It is very, very fast. It has its little quirks. I talked about it in the lecture. I'll publish the VOD later. It has its little quirks. But who doesn't, you know? Nothing wrong with a few little quirks. Other cleanup I wanted to do was actually getting rid of these tests. Because half of this project has just become tests. Because I'm trying to like actually test my code before I fucking release it. And it's kind of getting big. Speaking of, let me double check that the file names are right. I'm not even like maxing out my CPU in the slightest. It like peaks at 15%. I don't understand how it's so fast. I feel like something is wrong. It's, well, it's not calling the files the right thing, so definitely something is wrong. ToString. Where would this be? This should be in manager. I'm calling ToString somewhere. There we go. Yeah. I need this. Maybe that's why it's so fast. It's not doing anything. Yonk. Wait, did I get this right? What was here before? DP count? I did get it wrong. Anywhere else? Two string? Maybe fixed? Maybe fixed. I think maybe fixed. Clean that up. Maybe. There we go. No, the maxi file extension gets deleted. Whatever. Still faster than Kafka, that's all I care about. I think Kafka's way slower, no? But it's not made to be fast. I think it's an unfair comparison. I think it's much more fair to compare to like, I don't know, Crossbeam? Unbounded channel, 5 million messages, sequential, 0.4 seconds. What's the size of the messages? Exactly 100 bytes. So it can technically be faster. I don't know. Does this even make sense? I'm worried it's not this is like too fast. It doesn't even make sense. Is 9 gigabytes a second even possible? That's a lot slower than Kafka? No, it's not. No, it's not. Peak throughput 600 megabits. 600? Kafka does 1 kilobyte at 8 gigs? Sequentially? I don't think that's true. I'm copying their I'm copying this benchmark. 1 kilobyte at 8 gigs is like, how many machines is that? I'm copying this benchmark. Because I have very similar specs here. So it makes sense to me to do this. Also, you know, even if that's true, I'm at 9. I'm at 9 gigs. Yeah, single producer thread, no replication, 78 megabytes per second. 50 million 100 byte records at 78 megabytes per second. 8 greater than 9 OP. It is also machine dependent, yeah. I mean, obviously this isn't like a super thorough benchmark, but I think you can like, if you're a magnitude faster or slower, then you can tell. Yeah, 40 megabytes for producing. I don't know. Kafka's not made to be fast. Kafka has linear scaling, which is insane, and I don't understand how that works. But what Kafka does is for every node you add, consuming is linearly faster. Producing, I think, gets slower. Producing gets slower at like a log scale, but consuming gets linearly faster, which is crazy. Because they copy messages. I mean, it's like, it's nothing like super crazy. I'm not like super well versed on the Kafka model, but it looks something like this. Writing faster than reading? No, reading is faster than writing. Because the Kafka model is just duplicating messages until it's fast. Where if you have multiple Kafka nodes, they all duplicate messages amongst each other. Like they'll replicate data amongst each other. And so if you're producing to one of them, it has to replicate data to all of the other nodes. This can happen asynchronously. You can set a setting to say that this happens asynchronously, so writing happens fast, but it technically doesn't propagate through the whole cluster. And you know, the write technically doesn't finish until it goes to every single node in the Kafka cluster. But what this means is if you add a consumer, the consumer can consume from any one of these nodes. It can choose which node to consume from. Which means that if you, let's say, have one consumer, it's just going to consume from one of them. And that'll happen, you know, like at a speed n. If you add another consumer, it's just going to go ahead and consume from a different node. And it's going to say, give me all the give me all the even messages. This one's like, okay, give me all the odd messages. They technically never compete with one another. So now they're reading messages at 2n. It's a linear scaling. It's linear scaling as long as you have enough nodes. So producing becomes slower with every node, but consuming gets linearly faster. So it's really cool. Instead of waiting, just clone. Exactly. Yeah. And Kafka does a lot of this on a lot of different levels of like partitions and things like that. So it's very, very cool. Which technically Franz can do. Ish. Technically Franz can do this too. Kafka does a cool thing called partitions, which is basically pretending that two topics are one. Like if you have a topic, which is just this big list, right? You know, I'm writing messages to my topic. And I have multiple producers and consumers. They're all going to be competing with one another. And it was kind of like what the lecture was about, but like they're all going to be trying to figure out like who's writing the next message. Who's writing the next message? Who's reading the next message? There's going to be a lot of context switching. There's going to be memory synchronization. Even if your algorithm is super fast and you have zero locking like Franz is super fast. There's no locking involved. There's still overhead of cache coherence. There's still overhead of memory synchronization. There are things that just have to happen, even if your algorithm is really, really fast, that for every consumer you add, you're going to get some like physical slowdown. You might still get a better speed, but for every consumer you add, they're going to get, you know, you're going to get less benefit. You're going to get less benefit for every consumer you add. So Kafka does a cool thing called partitions, which technically I can implement, but it's kind of hard, is you just say, okay, well, what if we just split up a topic into a bunch of smaller topics? Like, what if we just say messages that are divisible, I don't know, messages that with indexes that are divisible by 3 go into this one. Ones that are, you know, modulo 3 remainder 2. This is like equals 0. Okay, hold on. Let me make this cleaner. If index modulo 3 equals 0, if it's divisible by 3, we go here. If it has a remainder of 1, we go here. And if it has a remainder of 2, we go here. So now you can have 3 different producers, and you just make sure that none of them produce to the same topic. They always produce to a different topic, and all of a sudden they're not competing. You have 3 producers that don't compete at all, so they're again, you get linear scaling. And then if you have a consumer, it just needs to know, okay, I need to read from this one, and then this one, and then this one. And in Kafka calls these partitions. But it just basically splitting a topic into a bunch of smaller topics and pretending that it's one. And there's a lot of like fancy algorithms that go into partitions to make sure that like consumers are rebalanced. And like, how do you balance which partition to write to? Like, obviously it's not going to do this modulo system. This is very easy and this is very fast, but it doesn't work that well. So how do you like balance messages amongst partitions? That's like a cool thing that Kafka invented. Kafka invented many, many very, very cool things. It's just a lot of things, and it happens to be pretty full of bloat. Wow, I really can just yap about message queues for like 3 hours. That's crazy. Least surprising thing Maxi has said. There's also this is a fun thing. There's a Kafka children's book that explains all the same concepts. Since producers will be less than consumers, partitioning will be useful at large scales. Always, always, always. I mean, Kafka's all about mostly yapping. I'm on topic for the first time ever. Kafka's all about Kafka children's book. Hold on, I'll show it in a sec. Stream is yaptastic. Kafka's all about partitioning things at every scale. Because this, like, splitting things up into nodes, and nodes are different machines, right? Whether that's virtual or not, but splitting things up into different nodes is also a way of partitioning your data to make sure that you don't have these limitations on hardware. And then within every node, you also partition topics. And so like, it's just Kafka's all about like having smart ways of splitting up data where like, that's where a lot of the beauty is. Java is slow. They wrote Kafka in the slowest fucking language imaginable. It's clunky, it's terrible, but the way that it was designed is so incredibly smart that there's yet to be like a solid competitor. A lot of people just copy a lot of these Kafka protocols, which is just, it's really cool. There's a lot of very smart optimization that's going on that makes things so scalable. Very, very cool stuff. Yeah, there's an Apache Kafka children's book. Gently down the stream. An introduction to Apache Kafka. You could totally be Kafka. Yes, you just have to re-implement a lot of shit. I mean, there's two things, right? Like one thing is Kafka's stupidly scalable and it's well supported. It's well supported on like a global scale, right? It's easy for every single company to just throw in a Kafka cluster. How many lines of code is Franz? Not that many. Like a lot of it is just utility stuff, but I want to say like 500. I feel like it's definitely less than 1,000. It's not that many lines of code. It's just a lot of thinkies. Gently down the stream. A gentle introduction to Apache Kafka. Round robin publishing. This is kind of what I was talking about. What do I use Kafka for the most? I don't have a job. I don't use Kafka at all. The only message queue we use is for the Twitch bot. The forest was quiet in the beginning, with only 2 otter families living among the trees and rivers. Whenever they needed to share news, they simply talked to each other directly. They shared news about birthday parties, new visitors, and other events happening in the forest. Over time, more and more otters moved into the forest, and likewise, the number of events began to grow. This presented a challenge for the little otters. Whenever an otter had news to share, she would have to find every otter family and tell them directly. This not only took a lot of time, but was fraught with error. What if one of the other otter families was on a picnic and wasn't around to be notified? Well, the messenger would either need to try again later or just give up. Am I secretly the marketing head at a Pouchy Foundation? No, I've made my own message queue that's better. I made my own message queue that's better. I just have, as someone who's spent the last 6 months being obsessed with message queues, I I have to give credit where credit is due. You know, I've spent a lot of time reading about Kafka, message queues, implementing them, re-implementing them, re-implementing them. I've just learned. I've just learned a lot, and I gotta give credit. I gotta give credit to the Apache Foundation. They made a solid thing. And then they wrote a children's book about it. Since the otters talk to each other directly, just jumping back into it. 6 months is nothing. I know, but like for me, that's like 10% of my life, right? At my age, that's 10% of my life. You know nothing about message queues? You should have joined the lecture. Also, you're going to learn about it right now. We're going to learn about it right now. Being tightly coupled is super cute, but it makes communicating with lots of otters difficult. This is called a scalability problem. That's when one little otter named Nixie had an idea that would change the forest forever. The forest was home to a great river named Kafka, and she knew the otters could use the river to communicate. She even made a song to explain how it would work. Not singing the song. From university lecture to kids book? Exactly. I'm not singing the song. Let's see how this works. An otter would observe an event, which is something that happened at a particular point in time. As in, bees came back today. The otter would create a record of the event, which is just some information about what happened. Then the otters would decide which part of the river to put the message in, which is a topic. Oh my god. So if you like put it in the left river, that's the birthday events. The middle river is visitors. And the right river is forest alerts. Wow. So they throw it into forest alerts. The otters would drop their messages in the stream, parentheses topic, for others to find. At first, they tried using glass bottles, but the bottles just floated away. The otters switched to glass floats. Since the floats stayed in place and didn't float away, they were said to be persistent. This example makes no sense. Can I be real? This example makes no sense. It's definitely harder to interpret this than to just explain it, right? Am I crazy? I understand what they mean. They want to say messages are disk backed. They're persistent. So is Franz, by the way. Franz disk backed. There are two kinds of otters: producer otters and consumer otters. They're crazy for making a children's book. I don't know. He made it for his daughters. He made it for his daughters. It's cute. It's cute. How to stretch an analogy to its limits and beyonds. Yeah. I don't know. I think it's cute. He probably didn't think it would ever like anyone would ever read it, but then I think it got like ended up getting featured on the Kafka docs or something. Am I crazy? I don't know. I think there was just like a bit someone made a bit that Kafka's so simple you could write a children's book and understand it. Like even a child could understand it. And then they wrote this children's book that makes absolutely no fucking sense. Damn, partitions. The one member of each family called the group leader would assign subset of the smaller streams, parentheses partitions, to each family member. And then the Dawn Otter would tell the other Dawn Otters where to do their business. And if any of the Dawn Otters interfered with the main Dawn Otter, they'd have to go sink an otter. They throw the otter into the stream, tie a little stone to him, and that's how you know he's not the group leader anymore. Parentheses topic. Parentheses partition. Consumer groups. The animations are cool. Entire books have wait, well, what? Entire books have been written about this magical place, mastering Kafka streams, published by O'Reilly. Oh yeah, there's also Kafka connectors, which I don't really understand why they're special, but Kafka connectors are a thing too. I've had to write Kafka connectors, and then I gave up and I made my own message queue. Unironically, a lot of the reason I've been so obsessed with message queues for so long is because at work, I had to do. Sorry, I kicked my little camera there. At work, I had to do a lot of like unstructured data shit, and it was all in Kafka. And like I think a lot of like the Kafka ecosystem assumes you're working with JSON or like some form of structured data, and I just had like blobs of text that were my messages, and I kept getting frustrated that like a lot of the Kafka ecosystem just like doesn't handle blob of data in a nice way. I didn't have any Kafka connectors that worked the way I wanted them to. I needed to like this was back when microservices were way cooler, so I was writing a lot of microservices, and it was garbage. It was so garbage, and it never worked, and it wasn't stable. I guess in that sense, I haven't really changed as an engineer all that much. But that like started my obsession with message queues. That was my obsession with message queues because I was just like, this can't be right. This can't be right. Like this just isn't fun. And now we're here. And on that note, I'm sorry to keep it short, but I am fucking exhausted today. I have to call it. I'm sorry, gang. Lazy Sunday. I love the vibes. Don't get me wrong. I love the vibes, but boy oh boy am I exhausted today. Are message queues that complex? Should have watched the lecture. Should have watched the lecture. Who we sending us to? I feel like this music just puts me to sleep. Lecture was fun. I'm gonna send to someone who's also being a little productive, I guess. We're going to Museum. They do a lot of Rust dev stuff. And they have raids disabled. So we'll do someone else. He likely will ignore the raid. That's what I was hoping for. All right, we'll do expired popsicle. They have good vibes. They're a little more high energy than I have been today, but hopefully that's what we need. We'll see. We'll see how I feel about the lecture. I need to give it a little rewatch, see if I enjoy it. That's how I do content. If I can't enjoy my own content, then I think it's garbage. So I don't know. I'll give it a rewatch, and if it's fun for me, maybe we'll do another one. Other than that, I'm on my little 2-day break, and we'll be back on Wednesday at 4 p.m. Eastern. So I hope everyone has a lovely start to their week. Take it easy, and welcome back to school. I hope you all have a lovely Sunday. Hold up? Absolutely not. GG. You forgot to ask? You'll ask next time. I don't know what to tell you. Ask in Discord. Bye bye.